Hey there, welcome to a video on indefinite integrals and differential equations. So here we have 6 examples, and the first 4 examples, as you see here, all deal with indefinite integrals. So let's start with number 1. Now number 1's a pretty basic indefinite integral because you're asked to find the integral of a polynomial function. And remember that when you take the integral or the antiderivative, it's kind of the opposite of the power rule for derivatives. So right now it's x to the 1 power, so you increase the exponent by 1 and then divide by a new exponent. So basically, increase exponent by 1, then divide by new exponent. So for example, if you're asked to integrate 3x squared plus 2x plus 4, it will be 3x cubed divided by 3 plus 2x squared divided by 2 plus 4x over 1. And don't forget about the plus c. Actually, I forgot to put that over here, because you don't know if you could have a constant, since if you were to take the derivative of your answer, that should get you back to the original expression. So clean this up, you get x cubed plus x squared plus 4x plus c. And always as a check, as I just mentioned about a moment ago, as a check, if you were to take the derivative, so say for example y equals x cubed plus x squared plus 4x plus a constant, if you take derivative, guess what? You get 3x squared plus 2x plus 4, and of course the c just goes away. So you know that we did this right, because the derivative of our answer gets us back to the original expression. Now for number 2, in this case, you could FOIL x squared minus 1 4 times. Actually, what I really mean is you can multiply by itself 4 times, or use the substitution technique, or method, whatever you want to call it. So let's use the substitution technique. So here we have the integral of x squared minus 1 raised to the 4 power times dx. So in this case, we will let u equal x squared minus 1. So du over dx, when you take the derivative of u with respect to x, do it for both sides, you get that. So du equals 2x dx, or x dx equals du over 2. So now we substitute. So if I, first of all, rewrite this like that. So x squared minus 1 is obviously u. So that becomes the integral of u to the 4 power. And x dx is all this right here. So times du over 2. Because originally we had x squared minus 1 raised to the 4 power times x dx. Replace x squared minus 1 with u, so you have u to the 4. Replace x dx with du over 2, so you have u to the 4 times du over 2. Or 1/2 integral u4 times du. Notice how I kept the integral sign the entire time, because I haven't done the actual integration yet. I haven't done the antiderivative, or increasing the exponent by 1 and dividing by the new exponent. I have not done that yet. Now I will do that. So you get 1/2 times u to the 5th power over 5 plus c. And when you substitute back in for u, you're going to have x squared minus 1 raised to the 5th power. The 2 and 5 become 10 plus c. And that would be your final answer. You could always check your work too to see if you've done this right. So if we do a quick check, x squared minus 1 raised to the 5th power over 10 plus c. Let's say y equals that. So when you take the derivative, you're going to have 5 x squared minus 1 raised to the 4 power divided by 10. Then you got to do the chain rule, so derivative the inside. Derivative of x squared minus 1 is 2x. And of course, the derivative of c is just 0. So you wind up getting 5 and 2 becomes 1 and 2. The 2's cancel. So you get x squared minus 1 raised to the 4 power. What do you know? That's the same as the original. Same as that. Okay. More with integration by substitution. Let's look at number 3. So what should we let u equal? Always let u equal the expression of the highest exponent. So obviously the expression of the highest exponent is 4x cubed plus 5. Oops, let's make that a little more clear. Sweet. So du over dx has to equal 12x squared. And if you move things around, du equals 12x squared dx. X squared dx equals du over 12. So now, let's rewrite this. Let's write as 4x cubed plus 5 raised to the half power times 6x squared dx. So 4x cubed plus 5 already knows u, so it's integral of u to the half. X squared dx, we know is du over 12. So times 6 times du over 12. 6 and 12 become 1/2, move it out to the left. So now you have this. So 1/2 times u 3/2 divided by 3/2 plus c. The 3/2 on the bottom, remember it's got to flip. So it becomes 1/2 times 2/3 times u 3/2 plus c. The u we could substitute. So the 2's cancel here, so you get 1/3 times 4x cubed plus 5 raised to the 3/2 plus c. So we have that all figured out. Let's do one that involves trig functions. Now in this case, let u equal 1 plus cos x, because right now it's being raised to the 2nd power, so that'd be easier to let that be u, because then we'll have u squared, and then we can substitute for sine x later on. See, what happens here is that if u equals 1 plus cos x, du over dx will simply be negative sine x. Remember, the derivative of cosine is negative sine x. So du equals negative sine x dx, or sine x dx equals negative du. So let's rewrite this. The integral of 1 plus cos x squared times sine x times dx. So that would be the integral of u squared, and all this goes away, you put negative du in its place. So times negative du, or negative integral u squared times du. So you get negative u cubed over 3 plus c, because remember you increase exponent by 1, divide by a new exponent, and then put 1 plus cos x back in, so you get negative 1 plus cos x cubed over 3 plus c. Okay, now let's talk about differential equations. These are just like the previous examples. Only thing is that you must separate dy and dx. And that's simple. So dy over dx equals x squared plus 1 So all I'm really going to do is just multiply both sides by dx. Cancel, cancel. So dy equals x squared plus 1 times dx. So now integrate both sides, because you want to get rid of the differentials. dy and dx each represent a change of x and change of y. You want to get rid of that. To do the inverse of a differential, you obviously integrate. So now integrate both sides. So you have the integral of dy equals the integral of x squared plus 1 times dx. So y equals x cubed over 3 plus x plus c. Don't forget about the plus c. And that's it. You solve the differential equation. Because when you're asked to solve a differential equation, when asked to solve a differential equation, you must get y all by itself. And so we see here, we had dy over dx, so we multiply by dx, get rid of that. To get rid of the dy, we had to integrate it. And then we got y by itself. Okay, number 6 is kind of the same thing, but one little thing here. You're given an initial condition. But let's do the same thing. dy will equal x squared plus 1 times dx. So notice I'm doing the same problem as before. Integrate both sides. That's pretty easy. Y equals x cubed over 3 plus x plus c. Now use the initial condition. All that means is it's giving you an x and y value that go together. So I'm going to play 1 for y and 1 for x, because you're told that, right? So 1 equals 1/3 plus 1 plus c. If you solve for c, the 1's cancel on each side, so c is going to equal negative 1/3. So now your equation will be y equals x cubed over 3 plus x minus 1/3. And that would be answer number 6. So I think I've covered a lot of ground here. So we're all done. And hopefully you find this helpful. Okay, bye.